In this lesson, we are talking about if a situation is proportional or not. We will talk about graphs, we will talk about tables, and we will talk about equations. But first, let's discuss what a proportional relationship is. So, the definition of proportional means it has a constant ratio. To another quantity. Okay, I'll explain a little bit more about what that looks like for each graph and each table and each equation. But really, thinking back to the last lesson, it has the same unit rate consistently. Okay. Constant of proportionality is that unit rate. Okay. And you're going to find it by putting the y value over the x value. This is true if the relationship is proportional. We're just going to put y over x. Just a quick note, a lot of times, since constant of proportionality is a lot of words, we will often call it COP, capital C, capital P, lowercase o for that of. Just so you remember, if you see that later on in this lesson or in other situations, you can also abbreviate for yourself. But please make sure that you have these words written out at least once so that we recognize that COP or CP is the constant of proportionality, that ratio that we are looking at when you have a proportional relationship. So non-proportional, of course, is going to be if it does not have a constant rate. And there's another piece of information. Non-proportional means not a constant rate. So they could still have that relationship where they have a rate happening, but it might not be the same every time. Now, I do want to point out that that means that it's not the same rate after it's been simplified, okay? And, or, it does not pass through the origin. So if you have a table or a graph, you should see that it goes through 0, 0, and I'll show you how to identify that in an equation as well. But 0, 0 is the origin, the coordinate that we're working with there. Okay, so let's get into some examples. All right, our first example we're going to look at is a graph. So remember, there are two things that we're looking for. The first thing we're checking for is, does it have a constant ratio? Now, in a graph, I will identify that by saying, is it a straight line? Okay. So the first thing I have to see is that it's a straight line. If it has any kind of curve or if it changes directions at any point, then it is not going to be proportional. So the first thing I'm checking is the straight line. And the second thing I'm checking is, does it go through 0, 0? Remember, that's the origin. So let's check in this example. So I see a straight line here. And it does go through 0, 0. So this one is proportional. So when I find out that it's proportional, now I'm going to identify what is my constant of proportionality. So constant of proportionality. Remember, I can only find this if it's proportional. PROP there. Let's fix that. So yes, it's proportional. So what I'm going to do is I'm going to take a look at any of the points. I'm going to choose this one because I can easily see what's going on both the x and y axis here. Okay? You're going to want to check your scale. So I have this point here. So I always put y on top and x on the bottom. So this one, the y value, which is always your vertical axis, is 10 for that point. You do want to be consistent. If you choose this point for y, you have to be consistent with this for x. And the denominator in this case, oops, sorry, not 5, 2. We have 10 for y and 2 for x at that point. Now, I can pick this next point up, which would be 15 over 3, or I could pick this one up here, which would be 35 over 7, 50 over 10, right? So I can choose any of them, and they will all simplify to be the same thing. And if you recall, 10 over 2 is equal to 5, or 5 over 1, and that is my constant of proportionality in this particular case. I want you to give it a shot. So the first question you're going to answer is the graph proportional? If it is proportional, what is that constant of proportionality? Make sure you write that down on your paper, get your answer checked, and then put it in the Edpuzzle. Continuing on, we have tables. So checking tables is going to look a little different than it is for graphs. Now, of course, if you have graph paper and the numbers are reasonable, you are welcome to work on graphing this, but you're not always going to have reasonable numbers, so it is good to know that how to find if a table is proportional. So the first thing, does it have a constant ratio? So to do that, to check that, I am going to look and see how it changes each time. I'm going to always start with y over x, okay? 1 to 4 is plus 3, 4 to 7 plus 3, 7 to 13 plus 6, and 13 to 6 plus 3. Now, I'm not going to just stop right there because remember, I'm looking for a constant ratio when it's simplified. So I'm going to see if maybe I jumped over here on the left, okay? So I'm going to check these out. 0 to 1 is plus 1, 1 to 2 is plus 1, 2 to 4 is plus 2, and 4 to 5 is plus 1. So I have 3 over 1, and 3 over 1, and 6 over 2, which simplifies to 3 over 1, and then finally 3 over 1. So I have a constant ratio, okay? So in this case, the answer is yes, constant ratio of 3 over 1. But my second question is, does it go through the origin? So I'm going to do this in one of two ways. I'm going to look for is 0, 0 on the table. If there's no 0 at all in the x or the y column, then I will figure something out and I will check and see by backtracking. But in this case, we have a 0 and in the x column, and it is not partnered up with a 0 over here. So this is actually not proportional in this case, or non-proportional, because it doesn't go through the origin. Which means that constant of proportionality does not really help us, and it's not proportional. Now, this is something called the linear equation. We will get to a linear function situation next school year, but just wanted to recognize that just because it's constant does not mean it's necessarily proportional if it doesn't go through that origin. All right, so I mentioned before, one step is to check if it's proportional by looking for the ratio. So I'm going to look for, is the ratio constant? Okay, so 26 to 39 is plus 13, 39 to 78, not plus 13. Let's take a look here. 78 minus 39, and you are welcome to use a calculator. That answer is plus 39. 78 to 130. I'm going to check in the calculator by subtracting 78 minus 39 here, okay? Or 130 minus 78, and so on and so forth, okay? We have plus 52. And, of course, 130 to 146, which is 16, plus 16, okay? Now, it's unlikely that I'm going to simplify 13 and 16 the same way, but let's take a look here and see what's happening. 2 to 3 is plus 1, 3 to 6 is plus 3. 6 to 10 is plus 4. 10 to 12 is plus 2. So we're going to see if these simplify the same way. And I can actually tell right off the bat, this 13 and this 1 do not work because plus 13 divided by 1 is 13, and 16 divided by 2 is 8, so the ratio is not constant, which means it is non-proportional. That being said, I want to use this table for something really quick. So let's ignore the rest of this here. Let's say that I was told that this 2 and 26 and 3 and 39 relationship, let's cross those out. Let's say I was told that the ratio is constant. Now I need to figure out if it goes through 0. So I have this plus 13 and this plus 1. So I can backtrack from here to see if this is going to be a proportional relationship by checking for that 0, 0. So if I added 13 to get here, then I would just do the opposite, which would be subtracting 13. So 26 minus 13 is, of course, 13. And over here, 3 minus 2 equals 1. Okay, so 1 and 13 would be on this table as well. And if I subtract 13, I get back to 0. If I subtract 1, I get back to 0. So if this was consistent here, and I wasn't looking at the rest of that chaotic mess down there at the bottom, then I would be able to get back to 0, 0, which would make this constant and would make it proportional. But the ratio doesn't match, so it's not going to work in this case. Okay? All right, you give it a try. Is the table proportional? And if it is proportional, please tell me what is the constant of proportionality. In this case, it does not show a 0, 0, so make sure you backtrack after you've checked your constant. Finally, we have equations. So this one, we are going to continue with another lesson another time. But the first thing I wanted to point out was there is a particular format, which is y equals kx typically, okay? So y is just a y value. K is your constant of proportionality. And x is just your x value. So what I'm going to do is I am going to look. I need to see that there's nothing being added or subtracted after that x. Only something being multiplied by x will make it a proportional relationship. If I have something else, that means that I don't cross through 0, 0. That means I cross through at a different location. So, for example, I have y equals 3x over 2. Or sorry, y equals 3 over 2x. Or 3x over 2. They're both kind of the same thing. So, when I look at it, it's the same format. I have y here equals that 3 halves times x, and there's nothing with it. So this is proportional. So to find my constant of proportionality, I look at what is being multiplied by x. Well, in this case, that's 3 halves, because that is the number or the term being multiplied by x. Okay? And the last example here before you do your last U tries for this lesson, you are going to look here, and we have y equals 8x. So we have that format y equals kx, but in this case, it has the plus 3. The plus 3 means that this is not proportional. Because if we were to graph this, it doesn't go through the origin. It would go through y equals, or sorry, it would go through the point 0, 3. Okay? So, you try for the equations. Is this equation proportional for both of them? And if it is proportional, what is the constant of proportionality? Okay. So go ahead and give these two a shot, that one right there and this one right here, and get your work checked and have a wonderful time giving that mastery challenge a shot. Have a great day.